Hi everybody, so for a time we have been looking at completing the square, and now today we'll be looking at interpreting variables in the expression. So we're looking at expressions in the form ax plus h squared plus k. Right, so after we have represented a function in the form, each part of that form actually represents something on the graph. The A tells us whether the curve will be a maximum or a minimum curve. If A is positive, it will give us a minimum curve. If A is negative, it will give us a maximum curve. So positive A equal minimum, negative A equal maximum. Now if we want the turning point, or the coordinate for the turning point, then it's going to be negative hk. So we take the value of h and we negate it, and we put that with k, and that will be the coordinate for our turning point. And the equation of the axis of symmetry, which is the line that cuts the curve in half, is x equal negative h. And another thing to note is that k represents the minimum or the maximum value of the function. Alright, so here I have an example of a graph. So here's the axis of symmetry cutting that curve, that graph in half. That line is the axis of symmetry. And we said the equation for the axis of symmetry is x equal negative h. Now for the turning point, look at the graph. Here the graph is going down, and at this point it changes direction and begins to go up. So this point where it changes direction is called the turning point. And we said the turning point is negative hk. Now this graph has a minimum point. Because it is a right side up U, it is said to have a minimum point. So in this case, if you are given an equation, right, or a function, let's say 2x squared minus 5x plus 6. It's obvious that a would be 2, right? And a is positive. So from this, we would know that the graph would look like this, a right side up U. Next thing. So here we have a graph now that is turned upside down. The U is turned upside down. This is the graph that has a maximum point. So that means in this case, a would actually be negative. So if I were to have a function for this graph here, it would be negative something, negative 3x squared, something, something, something. So we know that a in this case would actually be negative. So the graph has a maximum value. Alright, so let's take it further. So let's say we complete this square, right, for this graph. So we completed the square for this graph. This one has no a, but the coefficient of, well, the a would be 1, right? And the fact that x squared was positive, it means that a is actually positive 1, which means that the graph is a minimum graph, right? So I said that the minimum value is the k, and k is also represented by the letter y, the minimum value. So in this case, the minimum value would be negative 15. And then we can actually say the value of x for which the graph is minimum is negative 4. and that is taken from this part. Remember, in previous slide, I said that the coordinate for the turning point is negative h, k. So k is the minimum value or maximum depending on the graph, and h, negative h, is the value of x for which the minimum occurs. Value of x for which the minimum occurs. Negative h is the value of x for which the minimum occurs. Negative h is the value of x for which the minimum occurs. Negative h is the value of x for which the minimum occurs. So the minimum value is the k, and the value of x for which the minimum occurs is the negative h value. So right here it says when x equals negative 4, the minimum value is going to be negative 15. So the value of x for which the minimum occurs is negative 4. So if we were to sketch this graph, it would look like this. So the minimum value is negative 15. So notice down here, it is lined up with negative 15. And the x that it should be lined up with is negative 4. So here is 5. So negative 4 is right here. And it lines up perfectly. So this point is actually negative 4, negative 15. And that's a small sketch.